grade 6. Today we are going to jump ahead in our Jump Math books to Unit 16. However, this unit is a nice continuation of Unit 13, our measurement unit, where we explored perimeter and volume. Today's lesson is a continuation of that, and we are going to be taking a look at volume. And today's lesson is called Stacking Blocks. You will find this lesson on page 164 and 165 in your Jump Math book. Your learning target for today is, I can find the number of cubes in three-dimensional stacks. Before we begin, let's review what volume is. Again, we're going to defer to Rob at Math Antics to hear his explanation.
Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to learn about another important geometry quantity called volume. Specifically, we're going to learn what volume is and what kind of units we use to measure volume and how we can calculate the volumes of a few simple geometric shapes. The first thing you need to know is that volume is a quantity that all three-dimensional objects have. But to understand what it means, it will help if we back up just a little and start out with a one-dimensional object, like this line segment. To measure a one-dimensional object, we need a one-dimensional quantity, which we usually call length. The length of this line happens to be exactly 1 centimeter, which is a common unit for measuring length. And in the Math Antics video about area, we saw that if we move or extend this one-dimensional line in a direction perpendicular to it by a distance of 1 centimeter, it forms a two-dimensional object called a square. Two-dimensional objects are measured by the two-dimensional quantity that we call area. Because the original line was 1 centimeter long, and we extended it a distance of 1 centimeter, the amount of area that this square occupies is 1 square centimeter, which is a common unit for measuring area. Okay, now imagine that we take that two-dimensional square and move or extend it in a direction perpendicular to its surface by a distance of 1 centimeter. It forms a three-dimensional object that's called a cube. And to measure a three-dimensional object like this, we use a three-dimensional quantity called volume. Volume tells us how much three-dimensional space, or 3D space, an object occupies. Alright, but how much volume does this cube have? Well, since it was made by extending 1 square centimeter, a distance of 1 centimeter in the third dimension, we say that its volume is exactly 1 cubic centimeter, which is a common unit for measuring volume. So square units are used to measure area, and cubic units are used to measure volume. Since square units are made by multiplying two one-dimensional units together, like centimeter times centimeter, we can abbreviate them using the exponent notation, centimeters to the second power, or centimeters squared. And since cubic units are made by multiplying three one-dimensional units together, like centimeter times centimeter times centimeter, we can abbreviate them using exponent notation, centimeters to the third power, or centimeters cubed. And just like there were different sizes of square units, like square inches, square meters, or square miles, there's also different sized cubic units, like cubic inches, cubic meters, or cubic miles. See how area and square units are related to volume and cubic units? And there's another similarity too. Do you remember how you can use square units to measure the area of any 2D shape, not just squares? Well, you can use cubic units to measure the volume of any 3D shape, not just cubes. To see how
To keep this video nice and short, I'm going to leave the explanation at that. So let's go ahead and open our Jump Math books to page 164, and we will give a couple of questions a try together. So you can see that number 1 says, use the number of squares in this shaded column to write an addition equation and a multiplication equation for the total number of squares. I think I forgot to mention we are on page 164. So you can see that part A has been done for us. One column of this shape is shaded, and we can see there are 3 squares in that column. There are 4 squares that each have 3 cubes. So 3 plus 3 plus 3 plus 3 equals 12. An easier way, perhaps, to write that is in a multiplication equation. So we know we have 4 columns of 3 squares, which is also equal to 12. Let's try part B together. We can see that one column is shaded and that column contains 4 squares. We see there is a second column that also has 4 squares. So 4 plus 4 is 8. Alternatively, we can write a multiplication equation. There are 4 squares in each column and there are 2 columns. 4 times 2 equals 8. Please try C by yourself. Now let's look at number 2. How many blocks are in the shaded row? Okay, there are 4 blocks. You go ahead and do B and C. 3A. Write an addition equation for the total number of blocks. Use the number of blocks in the shaded row. So we can see there are 4 blocks shaded. So 4 in the first row, 4 in the second, we'll call this the first, the second, and the third. 4 more blocks in the third row for a total of 12 blocks. Please write a multiplication equation for the total number of blocks. Then try question 4 by yourself. Question 5 is on page 165, and it says, write an addition and a multiplication equation for the total number of blocks. Use the number of blocks in the shaded row. I would like to try part B together. We can see that there are 1, 2, 3, 4, 5, and another 5 is 10. So there are 10 blocks shaded in the first row. We can see that there is 1, 2, 3, 4 rows, and there are 10 blocks in each of those rows. I'm going to add 10 4 times for a total of 40 blocks. To write that as a multiplication equation, let's write 10 blocks times 4 rows equals 40 blocks. Please try part A and part C on your own. Question 6. Clara stacks blocks to make a tower. She finds the number of blocks in each tower by multiplying the number of blocks in the base by the number of layers. Write a multiplication equation for the number of blocks in one layer. So we can see that she has built a layer that is 3 blocks by 2 blocks. 3 times 2 equals 6 blocks. So let's jump down to part 1 of question B. So blocks in each layer we've determined is 3 times 2. Now how many layers are there? We can see that the second layer is the same as the base. So there is 2 layers. So the total number of blocks is 3 times 2 times 2. 3 times 2 is 6, times 2 is 12. Please try part 2 and part 3 on your own. Question 7 says, write a multiplication equation for the total number of blocks. We can see that the base in part A is, 3 blocks long and 4 wide. So 3 times 4, and we can also see that it is 2 layers high. So 3 times 4 is 12, times 2 is 24. This is interesting. We know our formula for area is length times width. I think you're beginning to discover that the area for volume is very similar with one small change. It is also length times width, but now we must consider the height of our shape. So length times width times height is the formula for volume. So we can see in part A, the length was 3 squares right here. The width, I'm going to write, this is an L, that was a lowercase l. The width is 4 squares, and our height is 2 squares. Length times width times height equals volume. Please try part B and part C on your own. All right, final question. How many blocks are on one side of the tower? What is the total number of blocks? So sometimes it may be easier to count a side rather than a base. So we can see it is 3 blocks high, 2 blocks wide, for a total of 6 blocks in each column. The total number of blocks then is 3 times 2 times 1, 2, 3, 4. 3 times 2 is 6, times 4 is a total of 24 blocks. Please try part B and part C on your own. Well done! You are done for today.